On the topic of light speed travel, you would begin at, say, any regular speed, and from there it's an infinite gap to light speed because we can't reach it. But say you made that infinite gap, now you're going at light speed. Just like all the other particles of light out there, all those waves of light. Except there's a problem. You're not like all those other particles and waves of light because you're not a wave. You're distinctly made up of particles, not made up of waves. So when you approach and match and then begin to exceed the speed of light, you begin to experience a kind of friction that is, unbeknownst in contemporary science. You see, as light behaves as both a particle and a wave, once you start going faster than light, you're going to start hitting it, and light's everywhere. Look up to the stars in the night, you see light, especially close to a star. Closer you are, the more light there is. But in any case, as you let's look at it from the light's point of view. So light can pretty much go through itself, because all light behaves as both a particle and a wave. It just kind of flows through each other like two mesh screens that kind of just are both the dots and the lines at the same time. They just kind of flow through each other. But you being a solid object, that's not what happens. Light bounces off you. So from light's point of view, it approaches you and then it bounces off. But all of a sudden, you're approaching light, and it's getting pushed away. Now, this is going to require force, hence friction. As you exceed the speed of light, you encounter a new type of friction. Personally, I call it science friction. It might be science fiction today, but it's tomorrow's science friction.